differentiation and integration formulae for hyperbolic functions. It's actually simple. First of all, we know that we have sin h of x equal to e to the power x minus e power minus x divided by 2. From this we get d by dx of sin hx is equal to d by dx of e to the power x minus e power minus x divided by 2. This is nothing but what? E power x, 1 by 2 into derivative of e power x is e power x, derivative of e power minus x is negative e power minus x, so negative and negative is positive, e power minus x divided by 2. This is nothing but cos h of x. Okay, therefore d by dx of sin hx is equal to cos hx. d by dx of sin hx is equal to cos hx. Therefore we can say that integral of or antiderivative of cos hx dx is equal to what? Sin hx plus a constant of integration. Okay, then in a similar way we can show that derivative of cos hx equal to sin hx because d by dx of cos hx is equal to d by dx of e to the power x plus e power minus x divided by 2. This is nothing but 1 by 2 into derivative of e power x is e power x, derivative of e power minus x is negative of e power minus x. This is nothing but sin h of x. So d by dx of cos h of x is equal to sin h of x. So we can say that what? This integral sin hx dx equal to cos hx plus c. So the important thing to remind here is that we have the derivative of sin x is cos x and but derivative of cos x is negative of sin x. But in the hyperbolic functions, derivative of sin x is cos hx and derivative of hyperbolic cosine is nothing but sin hx. Okay, no need of negative here. Okay, it's important. Now how can we find the derivative of tan hx? Okay. Now derivative of tan hx. D by dx of tan hx is equal to sec h square x. Now to prove this, we have the d by dx of tan x equal to sec square x. Here also d by dx of tan hx equal to sec h square x. So how to prove this? We know that. So to prove this, d by dx of tan hx is equal to d by dx of tan hx can be written as sin hx divided by cos hx. So we can prove this by using quotient rule. We know that by quotient rule this is equal to cos hx into derivative of sin hx, which is cos hx, for d by dx of sin hx minus sin hx into d by dx of cos hx all divided by what? Cos h square x. We need to prove this is equal to sec h square x. This is equal to, this is nothing but cos hx into derivative of sin hx is cos hx. So cos hx into cos hx minus sin hx into derivative of sin cos hx is also sin hx divided by cos h square x. So from this we get what? This is equal to, this is nothing but cos hx into cos hx is cos square x, cos h square x. So cos h square x minus sin h square x divided by cos h square x. So this is nothing but cos h square divided by cos h square is 1 minus sin h square divided by cos h square is tan h square. Sin h square divided by cos h square. This is equal to so no need of that. This is actually cos h square divided by sin h square is equal to 1 divided by cos h square x. So this is equal to sec h square x. So therefore d by dx of tan h of x is equal to sec h square x. Okay. Therefore we can say that integral of or antiderivative of sec h square x dx is equal to tan h x plus c. The integral of sec h square, not sec x, the integral of sec h square x is equal to tan h x plus c. Okay. In a similar way we can do that. So we got derivative of sin h x equal to cos h x. So integral of cos h x equal to sin h x plus c. The derivative of cos h x equal to sin h x. Therefore integral of sin h x dx equal to cos h x plus t. And the derivative of tan h x equal to sec h square x. So integral of sec h square x equal to tan h x plus c. Next one is d by dx of cot h x. This is equal to minus cosec h square x. Okay, to try to do this, therefore we can say that integral cosec can be also written as CSC. Okay, cosec h square x dx is equal to negative cot h x plus c. Okay, in connection with this, next one is integral d by dx of sec h x is equal to minus sec h x tan x. So from this we get what? Integral sec h x tan h, this is tan h x, sec h x tan x dx is equal to negative of sec h x plus a constant of integration. Okay. Next one is d by dx of cosec h x is equal to minus cosec h x into cot h x. So this implies integral what? Cosec h x into cot h x dx, which is equal to cosec h, negative, this is integral negative cosec h x plus c. Okay. So try to prove these identities and this derivative. Okay. These three you can try and you will get this answer. Okay. Next we can do some problems by using this simple problems. Okay. First one is differentiate. Now question 1 or question 3a2. Differentiate sin h of some 3x plus x cube. Now how to differentiate this sin h of 3x plus x cube? So to differentiate this, first of all we need to use the chain rule. So simply we know that what? D by dx of sin h of x is equal to what? Cos h of x. So therefore d by dx of sin h of 3x plus x cube will be what? So we need to replace x by 3x plus x cube. So dy dx of sin hx equal to cos hx. So simply dy dx of sin h of 3x plus x cube will be what? Cos h of 3x plus x cube into, by chain rule, into dy dx of what? We take this as x, 3x plus x cube. So this is nothing but what? This is equal to what? Derivative of this is 3 plus 3x cube. So 3 plus 3x square into derivative of the into cos h of 3x plus x cube. This will be the answer. Okay, this is the question. Now next one, we can pass on to next question. Find the derivative of, or find Q3. Evaluate or find d by dx of cos inverse of tan hx. You think about the answer of this question. We need to find the derivative of a function of a function rule where the first function is cos inverse and the inner function is tan hx. So we need to find the derivative of cos inverse of tan hx. So before for that we need to find first, we know that what? D by dx of cos inverse of x. What was that? D by dx of cos inverse of x is equal to, what was that? Negative 1 by root of 1 minus x square. Okay, d by dx of cos inverse x. So here d by dx of cos inverse x is equal to negative 1 by root of 1 minus x square. So we need to replace x by, we have d by dx of cos inverse of tan h of x. So we need to replace x by tan h of x, and we need to multiply the product of tan hx also. Okay, so therefore d by chain rule, actually d by dx of cos inverse of tan hx is equal to d by dx of cos inverse x is equal to negative 1 by root of 1 minus x square. So d by dx of cos inverse of tan hx equal to, replacing x by tan hx, will get negative 1 by root of 1 minus x square will be, so here x is tan hx. So 1 minus tan h square x into d by dx of the x. So here x is tan hx. So d by dx of tan hx. So this is nothing but what? Negative 1 divided by square root of 1 minus tan h square x is equal to 1. 1 minus tan h square x is equal to sec h square. Actually we proved this actually. This is sec h square x. So into d by dx of tan h x. Here 1 minus tan h square is equal to sec h square, means 1 minus sin h square divided by cos h square. So cos h square minus sin h square divided by sec h square. Okay, we already proved this. Okay, so this is if not we can prove like this. 1 minus tan h square x is equal to 1 minus sin h square x divided by cos h square x. So this is nothing but cos h square x minus sin h square x divided by cos h square x. This is nothing but cos h square minus sin h square is equal to 1 divided by cos h square x. This is nothing but sec h square x, right? So we can replace 1 minus tan h square divided by sec h square x. So square root of 1 minus tan h square x is equal to root of 1 minus sin h square. This is equal to minus 1 by sec x, root of sec h square x, into derivative of tan hx. Derivative of tan hx is what? Sec h square x. Derivative of tan hx is sec h square. So this is nothing but negative of secant x. Secant square divided by secant x. This is negative of secant x. Okay. So the derivative of cos inverse of tan h of x is equal to negative of secant x.